All right, everyone, let's review our work. So for number 1, we had x to the negative 1. We don't need to simplify. There's nothing to do the product rule. There's no quotient rule. So we got to look at that x to the negative 1 and think, how could I use my negative rule to write it as a positive exponent, right? So since I see the negative 1, we're going to move it and lose it. We write it as a fraction. We move it to the denominator. And now we're left with 1 over x to the negative 1. 1 over x to the 1, because we lose that negative. Number 2. Very similar. This time it's y to the negative 3. We move that over 1, and we take a look at that closely. And we need to move it and lose it. 1 over y to the third. There is no product rule. There is no quotient rule here. It's just rewriting. Okay? And now we got number 3. Y to the 4th times z to the negative 2. Here, we have to ask ourselves, can we simplify? Well, there is multiplication, but the bases are not the same. There is no division, so we're not using the product rule or the quotient rule. Here, we want to break up our problem, right? Y to the 4th, z to the negative 2 is y to the 4th times z to the negative 2. If we write this as a fraction, this might help us a little bit more identify how to rewrite that negative exponent. That y to the 4th will stay the same because it's a positive exponent. And then we have z to the negative 2, which is a negative exponent. As we know, we can change it, so we're going to move it and lose it. And now we're left with 1 over z squared. Now we can use our rule for multiplying fractions, multiply the numerator. We're left with y to the 4th times 1, which is just y to the 4th. And then in the denominator, 1 times z squared, which is just z squared. Number 4 is similar to actually numbers 1 and 2, 5 to the negative 3. It's just a number. We're writing these over 1 just to help us identify where our exponent and base is going to move. So we're going to move it and lose it again, and we're left with 1 over 5 to the 3rd power. Let's take a look at number 5. Number 5, it says 3x to the negative 2, y to the 5th. Again, we look at that and we ask, can we simplify any further? We cannot use the product rule or the quotient rule. We're not dividing, and when we're multiplying, the bases are not the same. So we see that there is a negative exponent, so we're going to break this up and represent these numbers as fractions. So we put them all over 1, and we go through them individually. Look at that 3 over 1. Nothing can happen, so it remains 3 over 1. We look at that second one, x to the negative 2. We can move that to the bottom, right, using our negative exponent rules. We move it, and we lose that negative, and now we're left with y to the 5th over 1. Now we can multiply our fractions. 3 times 1 times y to the 5th is just 3y to the 5th. Our denominator, 1 times x squared times 1 is just x squared. Great. And number 6. Getting a little bit harder now. So now we have 4x squared y to the 3rd divided by 2x to the 5th y. So here we can do the quotient rule here, right? So we're going to try to simplify first. So when we simplify first, we look at our coefficients. We could do 4 divided by 2, which is 2. Then we can do our x squared divided by x to the 5th, which is x to the negative 3. And lastly, y to the 3rd divided by y is just y, because 3 minus 1 is y squared. Now we have 2x to the negative 3 times y squared. We cannot simplify any further, but we can get rid of that negative exponent. As we've done before, we're going to break it up, write it as fractions. 2 over 1 just remains 2 over 1. X to the negative 3 divided over 1 changes because of our negative exponent rule. We move it to the denominator and lose that negative. And now we're left with y squared all over 1. Multiply our fractions. 2 times 1 times y squared is 2y squared. And in our denominator, 1 times x cubed times 1 is x cubed. Here we have number 7. We have 3m to the 5th times 4m to the negative 6 times n to the 3rd. Here we ask ourselves, can we simplify? Yes, we can. We are multiplying, and we have bases that are the same. So we can simplify this even further. If you remember, we have to multiply our coefficients, so we can kind of break this up again, if this helps. Going back to what we've done before. 3 times 4 is just 12. M to the 5th times m to the negative 6 is m to the negative 1. And n to the 3 has nothing to combine to, so it's n to the 3rd. Again, now we have a negative exponent, and we can rewrite this. 12 times m to the negative 1 times n to the 3rd. We put them over fractions, easier to visualize. 12 over 1 stays the same. M to the negative 1, since it's a negative, we can move it and lose it. We have 1 over m to the 1st power times n to the 3rd over 1. N to the 3rd stays because there is no negative exponent. I noticed in some of your work that some of you just like dropped everything to the denominator. You only drop it to the denominator when there is a negative exponent. And lastly, we have number 8, which is a little bit more complicated, but when you really break it down, it's not as bad as it looks. We have 7x to the 4th y squared times 3x squared times y all over 2x to the 5th y to the 7th. So again, we look at this and see if we can simplify, and yes. We are first going to do the product rule in the numerator. When we do the product rule, 7 times 3 is 21. X to the 4th times x squared is x to the 6th. Y squared times y is y to the 3rd because of that imaginary 1. And then in the denominator, it's left still to 2x to the 5th, y to the 7th. Now we can simplify even further. We can use the quotient rule. 21 divided by 2 is 10.5. X to the 6th divided by x to the 5th is just x. Y to the 3rd divided by y to the 7th is y to the negative 4th. Now we can go back to, now we can use our negative rule, negative exponents rule, and we can get rid of that negative exponent. The 10.5 over 1 stays, the x over 1 stays, the y to the negative 4, we can move it and lose it. We use our knowledge of multiplying fractions, and we have 10.5x in the numerator and y to the 4th in the denominator. And that is it. Okay, so you want to remember to see if you can simplify first, then simplify.